Have you ever thought about what makes a scientific theory powerful? We're going to dive into a concept that's, totally central to how science works, but it's also a bit of a head scratcher. We're going to figure out why, counterintuitively, a theory's strength has everything to do with how easy it is to prove wrong.
All right, let's jump right in with a puzzle that seems to completely defy common sense. It's a question that really gets to the core of what we're looking for in a good scientific explanation.
So here it is. Why on earth would we prefer a theory that's more vulnerable, one that puts its neck on the line, over one that's kind of safe and hard to argue with? It just feels backward, doesn't it? Let's look at a quick example. Okay, on the left, we've got this super vague statement: the universe contains hidden energies. I mean, how could you ever prove that's wrong? You can't. It's safe. But then on the right, you have a very specific, very bold claim. All planetary orbits are circles. Now, we know for a fact this is false. Yep, Kepler figured out orbits are actually ellipses. But here's the crazy part. Science sees the theory on the right as a much, much better scientific theory. And to get why, we need to unpack two key ideas. The solution to this whole paradox is all about understanding that we can measure what a theory contains in two completely different ways. So let's break them down. First up, there's what we call logical content. You can think of this as a theory's internal muscle. It's basically everything you can logically figure out just from the theory's main statements. The more stuff you can derive from a theory, the greater its logical strength is. And then on the flip side, we have empirical content. Now, this is the theory's external power, how it connects to the real observable world. And it's all defined by what the theory forbids. It's the whole list of things that, if we saw them, would prove the theory is false. So the more things a theory says can't happen, the more testable it is, and the higher its empirical content. What's so great about this slide is how it just lays that contrast out, right? Logical content is always asking what follows from this. It's about what the theory lets you say. But empirical content asks a totally different question: what would prove this false? It's all about what the theory denies. One is looking inward at its own logic, and the other is looking outward at the world. So you're probably wondering, okay, do these two things just move together? And, well, for purely scientific statements, a lot of the time they actually do. There's a sweet spot where that logical strength and testability go hand in hand. This slide kind of breaks down how that relationship works. See, when we're talking about theories that are strictly about the world we can observe, the rules are pretty straightforward. A theory that's logically stronger, one that implies more things, is also going to have at least as much and probably more empirical content. It just makes more claims, which means it has more chances to be proven wrong. So, here's the bottom line. Making a bigger, bolder claim that's high logical content means you are also making a riskier claim. That's high empirical content. They really are two sides of the same coin. But what if they're not? Okay, this is where things get really interesting. It is actually possible to drive a wedge right between these two measures, to pump one up without touching the other at all. And it happens when we introduce something that just can't be tested. But let's start with a classic, super simple theory. All swans are white. This has obvious empirical content. What does it forbid? Well, it forbids a non-white swan. Finding just one black swan is all you need to completely falsify it. It's super testable. Okay, now watch what happens. We take our original theory and we tack on this purely existential statement. And there are white ravens. Think about it. Could you ever prove that new part wrong? No way. You'd have to check every single raven that has ever existed or ever will exist. It's totally unfalsifiable. So what does this little trick do to our two measures of content? And this just brilliantly shows the split. The logical content, it shoots up because our new theory, P, implies everything our old theory, Q, did, plus this new bit about white ravens. It is logically a stronger statement. But the empirical content, it hasn't budged. Not one bit. The only thing that can falsify theory P is still the exact same thing, finding a non-white swan. That white raven bit adds zero testability. We've made the theory logically bigger without making it any riskier. All right, let's bring this all home and finally solve that paradox we started with. Why does science love a theory that is easier to prove false? It's because that's just another way of saying it has high empirical content. This chart just lays out that inverse relationship perfectly. You've got your vague theory like hidden energies exist.
Logically, it's very probable because it doesn't rule much out, but because of that, its empirical content is basically zero. Then you have the specific, precise theory, like all planetary orbits are circles. Logically, it's improbable. It's such a specific claim out of all the possibilities. But that's what gives it such massive empirical content. It tells us a lot about the world by forbidding every other possible orbital shape. Man, this quote just hits the nail on the head. The real scientific information in a theory isn't in what it says is true, but in what it says is false. A theory's real power comes from the sheer number of things it says can't happen. It's like it carves out this tiny slice of reality and says, the truth is in here and nowhere else. Okay, let's use one last analogy to really lock this whole idea in place and make the difference between logical and empirical content totally unforgettable. So imagine a scientific theory is like a set of blueprints for some machine. The logical content? That's everything you can get from those plans. Every schematic, every single part on the list, every instruction, the whole shebang. But the empirical content? That's the list of stress tests. It's all about what happens when you actually build the machine and try to break it. How many different ways can it fail if those blueprints are wrong? And here's how you get that split we talked about, using our analogy. What if you add a little note to the blueprints about, say, the color of the factory ceiling where the machine is going to be built? The blueprints are now logically bigger. The total amount of information has gone up. But does that change how you test the machine itself? No, not one bit. The number of stress tests, the empirical content stays exactly the same. And that brings us right to our final big thought. Science, it turns out, isn't just about collecting facts that seem right. It's about making these bold, precise, and really risky claims about how the world works. A theory's value isn't just in the story it tells, but in the giant target it paints on its own back. So I'll leave you with this. What do you think is more important for pushing us forward? What a theory explains, or what it dares to be wrong about?